Hello guys, welcome to another interesting session of this super premium course of my project ideas, and we are in the DSA course, that is data structures and algorithm. So in the last lecture we studied about the theta notation. We looked about why the theta notation is used, in which case it should be used, and what are the limitations of theta notation. But today we are going to dive into another interesting topic, that is analysis of the loops. The common loops which we basically use in certain different algorithms, certain different programs. So loops are something which is a very basic thing, and normally in like one in two or three programs has the usage of loops. So brace yourselves and let's start today's topic, that is analysis of common loops. Here we go. So first let's look about big O of 1. So the time complexity of a function or a set of statements is considered as big O of 1 if it does not contain a loop. If your program or your algorithm does not contain a loop, then it has constant time complexity, recursion, or any other call to other non-constant time function. So basically, if your program does not have a loop, does not have recursion we'll get to know when we move forward in this course. We will get to know what is recursion, what is loop, and what is a function calling another function, that is a calling function and a called function. But now at the time being, just get to know, if your program does not contain a loop or any recursion algorithm or any calling called function, then you have constant time complexity. For example, the swap function has big O of 1 time complexity. A loop or recursion that runs a constant number of times is also considered as big O of 1. So if a loop or recursion runs for a constant number of times, that is, if it is not defined by the user, you have given a value, you have given a constant value as to put a limit on the number of times a particular function will run in a loop or recursion, then that is also the time complexity will be big O of 1. For example, in the given program segment, you can see C is a constant. Your int I is equal to 1, I is less than equal to C, I plus plus. So your program's time complexity will be big O of C. As C is a constant, so we can write it as big O of 1. Got it? Because in time complexity, we basically eradicate the constant values, then the lower degree function. So we only take the higher degree. So if you have big O of C, that is a constant, so that will be equal to big O of 1. Then big O of n. Time complexity of a loop is considered as big O of n if the loop variables are incremented or decremented by a constant amount. If the variables in the loop, what are the variables in the loop? Basically, when you are inside a loop and you have certain expressions, and or your loop variable, that is, if you are using a for loop, inside the for bracket, suppose you have int n is equal to 1, and that n will be incremented in the increment or decrement section by n is equal to n plus is equal to c, suppose that will be a constant value. So if something like that happens, then your time complexity will become big O of n. For recursive calls, the time complexity will be big O of n. Let's take an example here. Suppose here c is a positive integer constant. You have a loop, for loop here, and inside the for bracket you have int I is equal to 1, I is less than equal to n, and I plus equal to c. So in each iteration, your I is incremented by a value c. So that's why this loop takes big O of n time complexity. Here it is decremented by a value c. So again, this will be big O of n. And this is a recursive function. Okay, what is recursive function? Here see, you are calling the function and you are passing a parameter. So in the first iteration, the recurse parameter will be n. In the next iteration, it will be recurse n minus 1. Then again, it will be decreased as such. So recursion is what? So it's basically, recursion is like, it's another way of writing a loop, but it happens inside a function. Then big O of, next is big O of NC. The time complexity of nested loops is equal to number of times the innermost statement is executed. So in case of the nested loops, what is nested loop? Loop inside loop. You are putting a loop inside another loop. So that time complexity, how is it determined? Is equal to the number of times the innermost statement is executed. So inside the inner loop, what statement you have? So the number of times that statement is executed, the time complexity of the number of the nested loop is such. So if you are a bit skeptical as what I said, no worries. Look at the example. Here is the example. So for I is equal to 1, I is less than equal to n, I plus equal to c. So this loop runs for n times. The inside loop runs for, see, for j is equal to 1 and j is less than equal to n, it runs for n times. So this loop, see, this runs for n times, and for even this I is equal to 1, this runs for n times. Again, when I equal to 2, again it runs, the inner one runs for n times. So as a whole, this total runs for big O of n square times. So the time complexity is big O of n square, n multiplied by n. Then log n. So time complexity of a loop is considered as log n if the loop variables are divided or multiplied by a constant amount. Important. So when you are dividing or multiplying the loop variable by a constant value, just remember that the time complexity becomes big O of log n. What is the example? Binary search. Very no-brainer example. It's log n base 2. That is log n. It is referred to as iterative implementation and has log n time complexity. So we can see that mathematically it is big O of log n because the base 2 is eradicated as such because it is a constant. So the series that we get in the first loop is 1, c, c square, c cube and ck. So first I equal to 1, then it will become 1 into c, that is c. In the next iteration it becomes c into c, that is c square. Then c square into c, that becomes c cube. So basically this goes on like that. If you are multiplying it by a constant number, that is c. If we put k equals to log n base c, we get c to the power log n base c, which is n. So if you put this k equals log n base c, so in the c to the power k part, if in place of k you put log n base c, so you get c log n base c. So if you know logarithm, that gets cancelled out and the value comes to n. Then log n. It is a loop. The time complexity of the loop is considered as big O of log n if the loop variables are reduced or increased exponentially by a constant amount. So if you are exponentially increasing something or you are exponentially reducing something, then the time complexity of the loop becomes big O of log n. So when there will be consecutive time complexity of the loops, for example, suppose there will be 3 or 4 loops. One will be a nested loop, one will be a normal loop, one will be a like exponentially increasing loop. So in that case, what do? You just sum up all you part the loops. Like for loop 1, the time complexity is this. For next loop, the time complexity is this. Then what do? You sum all the loops. And the final answer becomes the maximum of all that, because we have already studied the theory part of the asymptotic analysis that the lower order terms are anyhow discarded. Got it? Then, so how do you calculate the time complexity when there are many if and else statements inside loops? Good question. So the priority of the worst case time complexity is very useful among best, average and worst case. So we always take in counter of the worst case time complexity. Always remember, if someone is asking you about the time complexity, you always figure out that he is asking you about the worst case time complexity. Why do we take worst case consideration? Because it guarantees on the maximum resources an algorithm will consume. We should know that how much maximum the resources the algorithm is going to consume, because minimum is none of our business. If we know the maximum, we can define the algorithm is efficient or not. Then we basically focus on the situations where the algorithm performs, which is called scenario evaluation. How do you calculate the time complexity of recursive functions? The time complexity of a recursive function can be written as a mathematical recursion relation. Don't worry, This just keep in mind what is recursion, what is loop. We will see each and every topic in a very detailed manner when we move or when we proceed further in this course. This is gonna be a premium course which is gonna start from the basic layman point of view to an advanced point of view. So do not worry. The time complexity of a recursive function can be always written as a mathematical recursion relation. So if someone is more into mathematics, that person can get in touch with that. If you want to calculate the time complexity, you must know how to solve recursion and you must know how to write the mathematical representation of the recursion. So, okay, I know that was really, you guys got frustrated that so many log and so many expressions were there. So here is a cheat sheet for the algorithms, for each and every algorithms. And guys, this is really important because in interviews, these questions should be in your in your fingertips. And the interviewer might ask you that say me the worst case analysis of an insertion sort or a merge sort or a heap sort. So these are the standard algorithms which you should have in your fingertips. So have a look at it. I have provided the selection sort, bubble sort, insertion sort, tree sort, radix sort, merge sort, heap sort, quick sort, bucket sort, and counting sort. These are all these sorting algorithms. I guess for you, selection, bubble, insertion, radix, merge, heap, quick, these are the important ones. Rest, if you want, we can remember. And always keep in track of the worst case time complexity because that's gonna help you. So I hope you understood everything what I told you here.